Okay, yes, class. In the last class, we have completed the entire center of mass portion. So your test will be based on that. Now, starting with the kinematics of circular motion, class, the equations that we've already studied will be used as it is over here. Derivations also we'll see. So let us try to complete a major portion of this chapter so that we can soon start with gravitation. Okay, gravitation should also be ending. So the first equation of the kinematics motion, not in the circular one, in the translation motion that we have studied, that is V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. Third is V square minus U square is equal to 2AS. Now see, just instead of remembering these new equations, what you do, you remember the equations that you studied in kinematics of the linear translation part. Linear equations, remember, rotational equations, you can form the analogs. Analogs means, I hope you know, analogous means something which is similar. Similarly can be represented like, okay, torque we haven't done, no? So, linear displacement will become angular displacement. I told you all to revise the circular motion part and come in today's class because the circular motion will be used here as it is. I am continuing after that portion. We have discussed that part of the circular motion already in laws of motion before we did the dynamics of circular motion. So that part is already done. I am not repeating it. Theta, omega, alpha, all these definitions and everything were done there. So those portions you have to do by your end, and then only you'll be able to understand because I'm continuing. As I said, this chapter is lengthy, so that's why a little portion of it we have done together in the circular motion portion. Okay, so linear displacement will become angular displacement. Angular displacement is the angle swept by the body. U is the initial, see, U and other velocities. So velocities, linear velocities will become the angular velocity. So for representing the initial velocity and final velocity in translation, we had U and V symbols. Okay. So what you do for U, omega naught you put as the initial angular velocity, and final angular velocity you put just omega to differentiate. Like U and V symbols are different in linear. So in translation, in rotational, you just put a naught for initial. And alpha, which is the linear acceleration, will become a, which is the linear acceleration, will become alpha, which is angular acceleration. So you know these equations. Now you can frame the circular equation. See how V is equal to U plus AT. So omega is equal to omega naught plus alpha t. Time will be the same. Second equation, theta is equal to omega naught t plus half alpha t square. Like this, the second equation is also framed. Third is omega square minus omega naught square is equal to 2 alpha theta. So instead of remembering this, remember these. Remember what will become analogous to what are their analog forms. Then after knowing the analogous forms, you remember these, convert them directly. This is how you should be doing all the equations. Okay. Derivation, we have done derivations in the translational one also. But here also, let me discuss it once. Like, let's say the first equation, omega is equal to omega naught plus alpha t. Now, from here, we know alpha is equal to d omega over dt. So let's shift it here. So d omega will be equal to alpha dt. Let's integrate them. Initial time is 0. So at this initial time, what's the initial velocity? Omega naught. Final time is t. At the final time t, what's the final velocity? Omega. Initial velocity, final velocity. Initial time is 0. Final time is t. Now see, difference integration of d, any symbol dx gives you x. So d omega will be omega from omega naught to omega is equal to. Take alpha out. This will be t. dt, integral of dt will become t from 0 to t. Now you are going to put the limits. Upper limit minus lower limit. Also upper limit minus lower limit. Look, this will be omega minus omega naught is equal to alpha t minus 0. So omega minus omega naught is equal to alpha t. Omega is equal to omega naught plus alpha t. The first equation of motion. So that's how this derivation you will be doing. So equation remembering is easy. you can easily do it. These are the kinematics of circular motion. In your test, this part will come because there is nothing new that you have to do. Few things are new that I'll tell you what all things are there, and very small changes. Otherwise, the equations you all are already familiar with. Torque and all will not come in your test. Okay, please write it. Then we'll do the derivations of the other two equations. Please write it first.
Done, ma'am. Done, ma'am.
Done, ma'am. Okay, coming to the second derivation. See, here we know omega is equal to d theta or d theta by dt, right? Angular velocity is equal to d theta over dt. Now, see, d theta is equal to omega dt, right? Now, if I put the value, this I have written as d theta. This is dt. Now, value of omega we'll put from the first equation. See, omega is equal to omega naught plus alpha t. Now we'll put this here. So d theta is equal to omega naught plus alpha t dt, integrating it from 0 to theta, this integrating from 0 to t. Okay, so this will be theta minus 0 is equal to omega naught t from 0 to t plus. Now see, alpha will be taken out. This will become t square by 2 from 0 to t. Now just the limit substitution is left. Upper limit minus lower limit. Upper limit minus the lower limit. Theta is equal to, this is omega naught t minus 0 plus this is half alpha t square minus 0 square. So finally the equation is theta is equal to omega naught t plus half alpha t square. This becomes the equation. Okay. Let's also let us derive so that directly we can come to the numericals based on this, because in the test also, Learnivio's test also, it will be coming. So you all should be knowing this. See, if I say omega is equal to d theta over dt. Okay. In fact, I can start with alpha also. Alpha is equal to d omega over dt. Now what I do, I multiply and divide it by d theta. Okay, now d theta over dt is what? What? D theta over dt. It's omega. D theta over dt is omega. Otherwise, circular motion class, there is no point of studying this. We have already covered a portion there. Alpha is equal to d omega over d theta. This goes on the other side. D theta, alpha d theta is equal to omega d omega. Now from 0 to theta, and this is from your initial omega naught to omega. Okay, so see, alpha comes out, this becomes theta minus 0 equal to, this will be, see, omega is there, so omega square by 2 from omega naught to omega. We take the upper limit minus the lower limit. So this will be alpha theta. This is equal to omega minus omega naught, omega square minus omega naught square by 2. which is omega square minus omega naught square is equal to 2 alpha theta. Okay, these are the derivations in the NCRT. Now we'll come to the numericals, but first write down these derivations.
Ma'am.
See, let's practice some numericals on this. This says that on application of a constant torque, a wheel is turned from rest through 400 radian in 10 seconds. Okay. Now it is starting from rest. From rest means initial angular velocity is zero. Okay. Through 400 radian. 400 radian means radian is the SI unit of angle. That is displacement, angular displacement. So theta is given as 400 radian. Time is given as 10 seconds. Okay, it says find angular acceleration and angular velocity. Basically, we have to get what is alpha, what is omega. Yes, Sanidhi, which is the suitable equation according to you, which we should apply over here?
Oh, ma'am, theta is equal to WT plus half into alpha t square.
Yeah, that can be used for alpha. Theta is equal to omega naught t plus half alpha t square. See, this will be 0. So we will get theta is 400 now. So alpha will be 2 theta by t square, right? Yeah. So 2 into 400 by 10 into 10. That is equal to 8 radian per second square. And for the next equation, Sanidhi, like for omega,
Uh, Ma'am, omega is equal to how do you say it again? Omega,
not.
yeah, omega naught plus alpha t.
So this initially it is 0. So simply omega will be alpha into t. 8 into 10, that is 80 radian per second. Very good. So 8 radian per second square and 80 radian per second. These are the answers. Now the next question we'll discuss. For that, a note point I have to discuss with you all. First write it down, then the next one is from your NCRT. Let's continue with the next question. See, remember, when we talk about one rotation or one revolution, I hope you know the difference. Just think about Earth. When Earth rotates around its axis, that is one rotation, day and night. And when the Earth covers the complete rotation around the Sun, that is revolution. Okay, so when we talk about the angular velocities, we talk about RPM, everything in RPM. Okay. So one rotation is 2 pi radian, one revolution is 2 pi radian. So omega is one rotations per second or one revolutions per minute. So we will have to convert all this into the seconds form because this cannot be used. So what you do, whatever value you get, you multiply it with pi by 30. Why? Because we are multiplying it with 2 pi to convert it into radian and we are dividing it by 60 to convert it into seconds. So 2 pi by 60 is pi by 30. Answer will be answer will be in radian per seconds. So second question is from your NCRT. Angular speed of a motor wheel increases from 1200 RPM to 3120 RPM. So initially it is 1200 RPM, that is into pi by 30. This will be 40 pi radian per second. Initially, immediately converted. When you see the value in revolution RPM, just convert it into radian per second because that's not the SI unit. Omega, it is 3120. This will be into pi by 30. This will be 104 pi radian per second. Omega naught we have, the time stays in 16 seconds. T is equal to 16 seconds. First question says that what is the angular acceleration assuming it to be uniform? Okay, so yes, Tahura, tell me the equation. Which equation is applicable here, Tahura? Omega naught we have, omega we have, T we have, and alpha we have to find out in the first part. Yes, Tahura. Yes, Tahura. 3 equations we have studied. Tahura, are you there? I'll remove from the meeting those who are not then responding. Yes, Nabiha. At least even if the answer is wrong, that's okay. Discussion should be there.
Yes, ma'am. It's the W is equal to W naught plus alpha T.
Yes. Omega, see, the first equation is sufficient in this. Omega is equal to omega naught plus alpha T. So, see, omega is 104 pi. This will be minus 40 pi divided by time is 16. That's T in seconds. Second says how many revolutions does the wheel make during this time? Now number of revolutions. See, for the number of revolutions, calculate the value of theta first. Okay. Theta can be calculated using any of the equations. All the things are known to us now, so any value can be calculated. Use the third one. Theta, to find out theta, use the third one. Omega square minus omega naught square is equal to 2 theta alpha. Okay, so from here, theta will be equal to omega square minus omega naught square divided by 2 alpha. Now, once you have the values of alpha, remember number of revolutions is theta by 2 pi r. So this you can calculate and put it here. These calculations for the second part, please do it. It's lengthy. So let me know what's the answer you are getting. And Then straight away we'll start with torque. So kinematics part will be done. So first write down this. Okay, see, calculations you can do from your end. Let's come to the next topic, torque. Torque, the way we've studied, linear displacement is angular displacement, linear velocity, angular velocity, and all. So forces analog in the rotational motion is torque. Okay, so moment of force about the axis of rotation is torque. Let's say R is the position vector. I'll show you the figure. See, this is the graphical axis. This O is the actual axis of rotation. Okay, this is the axis that we are considering. So from the axis to a point P, the separation is R vector. From here, a force is applied. This is the applied force. Now see, in the formula of torque, no class, the formula of torque is basically R perpendicular cross F. Okay, this is R perpendicular cross F is the formula. R perpendicular means radius vector has to be perpendicular to the force. So this isn't. So what we do, we take this line of action of force, where the force is acting. See, if the force, let's say, is acting over here, so this is known as the line of action. This is known as the line of action. So you drop a perpendicular to this line of action. So this is considered as the R perpendicular. R perpendicular and now F, they are present. So you take the cross product. Cross product means, yes, Tahura, at least now try to answer this. Okay, she has left again. Mariam, you tell me, how do we open the cross product?
Yes, miss.
Open up the cross product, what do we use? A cross B is equal to AB cos theta.
Yes, miss.
AB sin theta. Cost will be there in dot product. So this will be RF sin theta. Okay. R perpendicular is the perpendicular distance between axis of rotation and the line of action of force. Okay. So line of action means you can take the line of action. Means it's not necessary that it has to be perpendicular always. Radius can be given you in any manner. You take out the perpendicular distance. Like let's say this is the axis. Let's say we are talking about the first force. So torque is equal to R cross F. This is R perpendicular cross F. So torque is equal to RF sine theta. Now look at the first force. This is the first force. This is the position vector. This is making an angle of 90 degree. So sine 90 degree is equal to 1. So torque will be equal to R into F, which is the maximum value because sine 90 is present. Whereas if I take this F2, its line of action is this and radius is also here. So this complete angle will be 180 degree. So when I calculate here, R perpendicular cross F, that is R F sine theta. So sine 180 degrees will be 0. So torque will be equal to 0. That is the minimum value. Okay, that is what is meant by torque. This is the formula of torque. Remember, this symbol is pronounced as tau. Okay, which is the symbol for torque, which is equal to take the magnitude of the perpendicular distance. This are perpendicular. Take the magnitude of force and take the sine of angle between them. So here for the torque, SI unit will be Newton into meter and it's a vector quantity. Its direction is given by right hand thumb rule, but right hand thumb rule you don't need to know it right now. Okay, class, is it clear? Is it clear till torque?
Yeah, mom.
What about others? Nabiha, Mariam, clear?
Yes, ma'am.
Yes, miss.
And Tahura, what about you? Have you understood? Write it, class. Other students write it.
Done, ma'am.
Okay, coming to the next topic, which is angular momentum. So we have studied linear momentum. What was the formula of linear momentum? Formula of linear momentum.
P equal to MV.
Yes, very good, Mariam. P is equal to mv. Now see, angular momentum when we talk about, this angular momentum is the rotation form of linear momentum only. Okay, this is represented by L. And like the torque is R cross F, this is R perpendicular cross P. Linear momentum. So here also when you open it, RP sine theta will come. Okay, so it's moment of linear momentum at the axis of rotation like this. See, here you take this R perpendicular. This is the point you drop along the line of action. Same thing will come. It's an axial vector. Mean its direction is along the axis of rotation, wherever the axis belongs. Axis of similar to that. Write down this angular momentum as well. Okay, class, from moment of inertia, just one topic, moment of inertia is left. So this I'll continue in the